What's up, everybody? Today we're diving into one of the most dangerously overlooked problems in IT and DevOps, which is insecure configuration files. These are the files that run your apps, servers, and your databases, and they're often containing passwords, API keys, and debug settings that attackers absolutely love to take advantage of. Today we'll be walking through a mini automated vulnerability scanner, and this is something that is lightweight that you could run during CI/CD. Maybe you could plug it into a Git pre-commit hook, using a security internship, or maybe it's just your first step into DevSecOps automation. By the end of this tutorial, you'll understand exactly how it works, why it works, and how real companies use these type of scanners to prevent million-dollar breaches. Without further ado, let's now start building out the tutorial, and the first thing that we'll do is import the OS as seen in line 1 above. This is going to let us interact with the operating system to affect files, paths, permissions, and etc. You can think about this like basically getting a file checker tool from a toolbox. Now that that is done, we'll be moving on to the next step, which is to define a function whose job is to generate a fake configuration file full of insecure settings. This is what create sample config will be. This is basically just like creating a recipe that'll make the configuration file for us. Now that we have our function defined, we'll move on to creating a variable called config, which will be starting a multi-line string. You can basically think of this like starting to write a letter with the triple quotation mark allowing us to have text across multiple lines. We can see that the db_password is set to admin123, and below that we can see db_user equals root, which sets the database user to root, which is a default admin in a very insecure setting, that is the default admin account. Moving on, we can see the API key being stored in plain text, which is a very big security problem. This is like writing your password down on a sticky note and leaving it out for anybody to see. Next, we'll be setting the debug mode to equal true, which basically can leak sensitive information and is like leaving detailed error messages visible for anybody to snoop through and see. The next insecure security setting we'll be creating will be SSL enabled equals false. This is highly dangerous as it will disable encryption, making your data vulnerable. You can think of this like sending mail without the actual envelopes. The next to last insecure setting we'll be creating will be admin password equals password. This is just using an extremely weak password which basically anybody can crack in their sleep. The final setting we'll be creating will be firewall disabled equaling yes. This is highly dangerous as it will disable your firewall and it's like removing all the locks from your doors. With all of this, we can now simulate the kind of mistakes that developers make in the real world. The next step is to open a file for writing. We'll start this off with open, and then open in closed parentheses, and quotation marks as well. We will next pass server_config.txt, which you can think of like opening a notebook to write in. We will next do quotation mark W, which means write mode to create or overwrite to the file. We will then has as f to name the file object f. We will now take the file object and pass it to the right, open and close parentheses, pass config, and this basically is going to write all the configuration text into the file, like writing all your notes into the notebook. Of course, no code is complete without printing a successful test message, which is what we'll be doing right here with this simple print string. First, we'll just be saying print with a box and a plus inside. That basically means that this is going to be a successful and positive action. We will next type create server_config.txt, which is basically like showing that we have a file created notification that will print to our terminal. We will be finishing this part of the code with a return function, and we'll be passing server_config.txt. What this does is returns the file name to the caller so that other functions can use it. You can think of this like handing someone the name of the file that you just created. Now that we have our insecure settings being written to a file, the next step is to create a function which will give us a checklist of problems and patterns which we will be searching for. For this, we'll name our function something simple like get_patterns. We will next start by returning the vulnerability patterns to search for. This will be done by creating a Python dictionary which will contain the definitions of all the vulnerabilities which we will be searching for. This part will be pretty extensive and long, so I will not code this out and will instead just rather copy and paste it, and we'll leave it below in the description for you to copy and paste as well. The first vulnerability we'll be defining will be the weak password. We can see that we will be searching for a password being admin or password being password, which is basically telling the scanner what to look for. Below that, we can see the severity set to high, which will tell us how serious this problem really is. Lastly, you can see that there is a message set to show when found. This is an explanation that will appear in the report. The next couple of vulnerabilities will follow the same pattern. As you can see in Exposed Secrets, it once again has the search, which is the list of patterns defined, the severity for how serious this is, and as well as a message for what to say when found. Next vulnerability settings will be the insecure settings, which will be looking for disabled security features set to a severity level of high. The last insecure settings we'll be making will be the default credentials. These are just the credentials that are typically used in environments and are easily guessed, so these are the ones that should be changed immediately with a severity level set to high. With our vulnerabilities defined, we next need to create a function that will scan the file for these problems. In the spirit of keeping our functions easily named, we will be creating this one and titling it scan_file. The first parameter we will be passing to this function will be known as file name. This is going to be the file which we will be scanning. The next one will be known as patterns. This is going to be the checklist of problems which we will be looking for. Moving on, we'll be creating an empty list known as findings. This will be here to store the problems found. You can think of this like getting an empty notebook to write down all the problems. Now that our list is done, we need to create an if statement to check and make sure the file actually exists, utilizing the operating system library. With the if statement done, we will now be printing an error message if the file does not exist. Almost forgot to add the little quotation marks to make sure that this is more easily displayed and read in the terminal when printed. Lastly, we will be utilizing the return, so that we will be getting back an empty list if the file does not exist. This is like saying that it can't check because the file is missing. Now that we have our if statement set up, we'll be moving on to the with part, so that we'll be taking with whatever we are opening with the keyword open. In parentheses, we will pass the file name, and then comma quotation R, which means read mode to read the file, and then we'll be naming it as F to name the file F. We now need to read all the lines, so we will be setting up lines will be equaling f.readLines. And then readLines is basically just saying that it will read all the lines at once, and then each of these lines will become one item inside of the list. With all these new items now being added to the list, we will need to create a for loop to make sure that we are looping through each line and getting the line number and content. Line_num will get the number, and then line itself will be getting the content. Enumerate is going to give both the number and the line. Start equals 1 will make it so that the line numbers will now start at 1 instead of 0. So with this line, we have now started the for loop and are able to move on to the next parts. Line 55 will be used to convert these lines to uppercase as well as to remove extra spaces. You can see this with the dot upper as well as the dot strip to convert to uppercase and remove any leading trails. With the case sensitivity now taken care of, we will be creating a nested for loop to go through each of the vulnerability patterns. You can think of this like checking off each category on a checklist. Vuln_name is going to be the name, kind of like a weak password, while as vuln_info is going to be the details, such as the search terms, the severity, and the message. Patterns.items is what we'll be using to get each of the patterns. Creating another nested for loop, this one will be used to go through every search phrase associated with a particular vulnerability pattern. So as the code loops through the dictionary, vuln_info will become that inner dictionary, whereas vuln_info search will be the strings that the scanner is searching for in the config file. Continuing with the code, you can see that we are going to be making another if statement. This is going to check whether the search terms like API key, password, or something like debug mode equals true appears anywhere in the current line of the configuration file. Findings will be used so that when a match is found, this will add a dictionary representing that vulnerability into the findings list above. Inside of the dictionary, we will be storing that within the line. This will store the line number of the file where the issue was found. Security analysts always need line numbers to fix issues quickly. With the dictionary content, this is what will store the exact contents of the vulnerable line. This helps you see exactly what triggered the alert, and this is what you would see in tools like SonarQube, SNCC, and Trivy. The next dictionary term we'll be using will be severity. This is the severity level that was already defined in the patterns above, like high or critical. This will pull that value so the report can group and count the issues. In real-world meanings, high usually means that you want to replace it ASAP, and critical means you want to drop everything and fix it immediately. The last dictionary we'll be appending will be the message. This is the human-readable explanation of the problem. An example of this would be like if a secret is found in a configuration file, then it should tell you to use an environmental variable instead. This is just the type of message that you'd see used in professional tools. To start closing off this line of code, we will now enter a break statement to exit the inner loop immediately, which is the loop that's scanning through each and every search term. And lastly, for this part, we will be doing a return findings, so that this return statement is outside both the loops, so that the scan finishes for every line, and it only then does the function return so that all the findings get sent back to their caller, main. If you're still keeping up with this part, I'm just going to congratulate you because this has been a long-winded tutorial, but do not worry, we are almost at the finish line. The final part we'll be doing will be defining a function whose job is to display the results of the scan. The name of the function to print the reports will be aptly named print report. The parameter we will pass will be the findings. This is the list of problems found. Again, to reiterate, this will not scan, this does not fix anything, its only responsibility is reporting. This next part, which will be the print statement, is basically just going to be printing out the vulnerability scan report to make the output look more professional in the terminal. This will help separate the report from the other console logs, and it's also the same style that's seen in CLI tools like Nmap and Nikto. Now that we have got that finished, we will be moving on to creating an if statement to check if no problems were found. This is like checking, is my list empty? And if the list is empty, it will print a clean success message and exit the function early, with no further reporting needed. With the if statement done, we will now be checking for the severity levels of critical and high. As you can see, we have critical equals sum, 1 for F in findings, meaning that we will add 1 for each finding, and then we will say if F severity is critical, meaning that it will only count the critical ones. This is a list comprehension, and while it is advanced, it is still very concise. We will then do the same thing to count the number of severity levels classified as high. During my recording, I made a little mistake right here and forgot to close the list of severity. So whenever you're going through this, make sure that you put the bracket to close the severity after the quotation mark. Using a print statement, we will now print out the summary stats, which will give you a quick overview before diving into the details. This is exactly what you'd show in an audit, a ticket, or a CI/CD pipeline. This is basically just going to print a summary of the findings and shows how many problems of each type are being reported. Moving on to the final for loop of the program, we will now be creating one that will loop through the severity levels with the most serious first. This is like checking the very urgent box first and then important as it goes through each security level. This ensures that the report always prints critical findings first, which is the same standardized ordering used in security tools. With a nested for loop, we are able to get all the findings of the severity levels. This is like asking to only get the critical problems or whatever it is back for that list comprehension. Utilizing another if statement, this is here to check to see if there are any findings of this severity. Utilizing another nested for loop, this one will now loop through the findings, numbering them. As you remember, enumerate will make it so that it starts at index 1 and not 0 for human readability. This will be like numbering the problems 1, 2, and 3. Utilizing a print statement, we will now print the line number and the content that shows where the problem is and what it says. IDX is going to be the numbers like 1, 2, and 3. The F with the line list is going to be the line number. This is where the vulnerability was found. The F with the content is going to be the exact contents of that file. And as you will see here shortly, the F message will be the human readable explanation. And to ensure our terminal output is read correctly, we will be adding a footer at the end that will basically resemble the header at the top that we used. We are almost done now. The last part is to define the main function. This is basically just like creating the start button. Much like before, we will be starting off with a print statement that will create a clear professional banner for the auto vulnerability scanner. This will tell the user what tool is running, and this is still the same vibe like how Nmap uses. Next, we will create a config file and store the file name, so that this is like creating a file and then writing down its name. This is just going to generate a fake and secure configuration file, write it to the disk, and then return its file name. This basically simulates scanning a live server configuration as a .env file or as a Kubernetes secret. After that, we will now load the vulnerability patterns. You can see that this is looking for all the vulnerability signatures like the weak passwords, API keys, and secure settings and the default credentials. Next, we need to scan the file and get all the problems found. This is going to be where the file is opened, where it's read line by line. Each line will be checked against each vulnerability category, and then the findings will be collected into a list. This is basically like your scanning engine, the heart of the program. To finish up the program, we will now be adding print statements. This is kind of like how real security tools always separate scanning from reporting, which we've already been doing correctly. We will now be implementing the final block that starts the program, which is the if name equals main, calling the main again in the file, which will execute it directly. We are now ready to test and run the application to see what will print. Running the application, we can now see the output is clean and easy to read in the terminal. With easy to read headers, we can see exactly what was successful and positive and shows what the program is doing. We can see that we found 8 total problems, with 1 being critical and 7 being high. You can see the critical issue was reported at line 3 with the API key as well as the reason. Moving on to the high issues, you can see the specific lines which they were found as well as the reasonings behind them being reported as well. This basically resembles how a real-world scanner would use when it's detecting vulnerabilities. And with this, we're basically wrapping up the automated vulnerability scanner. Thank you so much for listening and watching and staying up with me to this point. If you're still awake, be sure to like, comment, and subscribe to see more in the future. Thank you so much and have a great day.